Hi gang, and welcome back to OpenNMS 101, the video series where we attempt to bring up to speed on the OpenNMS network management platform. My name is Tar Spalog, and in this module, Module 8, we're going to talk about service assurance or service monitoring. Those of you who have managed to suffer through all of these videos so far might remember back in Module 0, I talked about the history of OpenNMS, and one of the things that we did there was create service monitoring, basically the ability to run synthetic transactions as a user would to monitor the status of a service being provided over the network. And we have a lot of service monitors. I'm going to jump over here for a second to the to a web browser. I've gone to docs.opennms.org, which is our documentation site. Under OpenNMS, I'm going to click on 1901. Horizon 1901 is the release that we're using for this exercise. And I'm going to click on HTML for the admin guide. Now down here in section 4 is service assurance, and it is a very detailed explanation of what I'm about to go through. We have a large number of monitors built into OpenNMS. Not all of them are included yet. There's some of the higher end monitors that aren't included, but at the low end, we have this idea of like an ICMP monitor. Is the service providing a ping? Is it providing the ICMP echo service? And then we have the TCP monitor down here. The TCP monitor will connect to a TCP port and listen to what comes back to make sure that something's available there. We have another other. We can monitor radius. We can monitor things about VMware, etc. On the higher end, we have monitors such as the page sequence monitor, which actually allows you to go and walk a series of web pages, such as is provided by a lot of web applications, and you can make sure that the web application itself is working. We also have a mail transport monitor, which isn't documented, which will actually send an email and make sure it arrived. We also have an integration with the tool Selenium, which is a web application testing tool. So you can go into Selenium, you can create a test that creates a Selenium XML file that you could then import into OpenNMS and use that to test whether or not your web app's running. So lots of really cool stuff. So when it comes to actually teaching service monitoring, I always kind of struggle with something to come up with. And so it dawned on me that, and we've been talking in the last couple of modules about SNMP. And SNMP, especially the net SNMP agent, has a really cool directive called extend. And the extend allows us to run a command locally on the machine. So unlike, say, an SSH monitor where you'd have to put passwordless keys and allow the monitoring service to connect via SSH, which requires a fork and exec and a lot of overhead, we can actually use SNMP to connect to the net SNMP agent and have it run a command and then get the result of that command back. And we're going to use that to create a service called class monitor. So we're going to test it from the command line, make sure it works. We're going to add the service to the node, and then we're going to modify the poller to actually poll the service. Now, talking about extend, extend is really cool. So it can run any script, basically. Anything that you can run from the command line, you can actually run from the extend command. Now, if the extend command is resource intensive, let's say you're doing something that's going to take 30 seconds to a minute or something to return, what you may want to do is to cron that and then just use the extend command to return the output of that cron. But in the case of this exercise, we're going to create a simple script, and we're going to just run it using an SNMP get. So what we're going to do now, I know not all of you are programmers, so I'm hoping this is not too scary, but here on my shell, I'm going to go to the temp directory, and I'm going to create a file called classmonitor.shell. And in it, I'm going to say that my shell is bash. And I'm going to run echo OK. I know that's a lot. It's a lot to process. But no, all we've just done is created a bash shell script that will echo the characters OK. And I'm going to save that. And I want to make it an executable. So I'll chmod, change mod, plus X to make it executable, class monitor.sh. And now when I run it, I get my OK back. Very, very simple script. But you can think about it. It's very, very simple, but you may have just a simple check you need to run on the system that looks at a file or some other value in the system, and it may be just enough to return that. Notice that in the script, I actually had to specify the shell. Now, if I take that out and actually run it, it works. That's because I'm in a bash shell when I run the echo OK. When NetSNP runs it, it is actually not running a shell. So put this back. Can't type and talk at the same time. So what will happen is we have to specify the language in here, this bin bash, in order to make this command work. So I'll test it again, and as you can see, it works. So this is our very, very simple command. Now, how do we put that into NetSNP? Well, we edit the snpd.conf file, and we just add the extend command, and I just put it at the bottom of the file. So what we're going to do is we'll edit etc, snp, snpd.conf, go down to the bottom, which is where I put all my stuff, and I put extend class monitor temp class monitor.sh. Now, you put the fully qualified path when you put your extend command in, and you also want to make sure, when I did this originally, I used to stick it in like var, but when SE Linux kicks in, sometimes it's very unhappy. And so I know that temp seems to be okay, but if you stick it somewhere else, you may have to modify your SE Linux permissions to allow the command to run. So this is going to create an entry in a table called extend, called class monitor, and it's going to run this command and show the output of that command. Now I'm going to quit out of here. And now I need to restart, so system control, restart snpd. That'll restart the command. Now, if I do an snp walk, -v2c -c, remember, why are you so nosy is the community string we're using, localhost, and I just happen to know that this table is .1, .3, .6, .1, .4, .1, .8072, .1, .3, .2. And so here's the output of that file. See, there's the SE Linux issue I was telling you about. Notice that it doesn't have permission to run this. Now I'm just going to cheat. I'm going to just set enforce equal to off. What is it? Set enforce 0. So what I really should do is make it so that SE Linux can actually fix this, but I don't know how to do that. I have to look it up, and so it's beyond the part of the class. So I'm just going to turn SE Linux off for the time being. But in a production system, you would want to enable whatever script you're running, you would want to allow NetSNP to run that script. And notice when I do it, I actually don't get that permission error. I actually get the output. So let's kind of break down these entries. Now, first of all, this is the top of the table. At the very top of the table, there is an NSExtend number of entries scalar. This is what that .0 means. It's a scalar that says there's only one entry in this table. You can have multiple entries. You can have tons of entries. And every time you have an extend entry, it will update this number. So we're going to stay limited to one for right now. It tells you what command we're running, temp class monitor.sh. There's no arguments. You can actually pass arguments with it. Now, this is something I want to see how many of you remember. This cache time, by default, NetSNP will cache any command for 5 seconds. This prevents someone from pounding, doing lots and lots of gets and killing your system by spawning lots and lots and lots of these scripts to run. So basically, it'll run only once every 5 seconds. So if I do a query and immediately do another query, it's only going to use the cached value. Now you can change that with a set, but that can be very, very annoying to have to do. So Jeff Gelbach, one of our guys, has actually submitted a patch to the NetSNP folks to allow you to set this value on the command line. I don't know if it's been accepted yet. It may take a while for that to bubble through all the operating systems. But in the future, if you had a query that might take a minute, you could change your cache time to be 60 seconds or 120 seconds, etc., so that it would only run once within a certain amount of time, which I think is kind of cool. We're executing it. It runs on read, which means it runs whenever we do the actual read. And the things we're interested in is the actual output, which is these final lines here. So it shows us the output of the first line, which says OK. Then the output full. Now, what does this mean? Let me edit my script. And I'm going to put echo foo, echo bar, and echo baz on here. And now when I run the walk, you'll see the output's changed a little bit. So you can see here the first line is still OK, but then it actually shows you the full output. So it's OK, foo bar baz, shows you all the different lines, and it tells you that there are 4 total lines. There was no error in running the command, and the first line is OK, the second line is foo, the second line is bar, the second line is baz. This can be really, really useful. Suppose you run a command, and the command gives you a bunch of output. I don't know if iwconfig is on here. No, I don't think. Install iwconfig. I used to run iwconfig. Yeah, it's in a wireless tools. But I used to run iwconfig, which would send output about the quality of the wireless connection. And then I used a script to break all the important stuff out into a single line. And then when I ran the script, I could find out this might be signal strength, this might be noise, etc. So you could actually go and grab all this information, parse it out one line at a time, and then use SNMP via OpenNMS to go and collect this information. Now I'm going to re-edit my script. Get rid of those. So now we're back to we've got the one line. So what we need to do now is we're going to need to actually pick something here to look at. So in this case, we could pick this value, we could pick this value. I prefer to pick this value. This is definitely the first line of the output with the .1. And so what we're going to do is we're going to actually monitor this object ID. Now, if NetSNMP knows about MIBs, it'll automatically compile them. So when you do a walk, you get all of this, it kind of interprets it as much as it can. You can add an option called -O for option, capital O, lowercase n for numeric. And now all the values come out in numbers. And this is what we're actually, this really long number here is what we're going to use to detect that this service exists and to monitor it. Now, what's kind of cool about this is if you look right here, this 99, this little section here, this is the instance of this particular entry in the table. And these numbers actually mean stuff. It's the word class monitor in ASCII. So 99 is an is a C, sorry. 99 is lowercase c in ASCII. 108 is an L. 97, which is 2 before C, is A. 2 S's, SS. Then we have an M-O-N. Remember, M comes before N, comes before O. And then, so we've got monitor. So it spells out class monitor. This is really cool because you might have, let's say, you want to run, I don't know, 10 extend scripts, and 3 are on this server, 7 on this server, only 1's on this server. Well, you can use this object ID instance to actually determine if a particular device supports this object ID, which I think is cool. I love NetSNP, huge NetSNP fanboy. So, okay, so I'm going to copy this because I'm going to need it. Now, getting back to the slides. So, explain the output. We should explain the numeric output. Again, 99, 108, 97, 115, 115, that spells out class monitor. Now, here's our exercise. So what I want to do is I want to create an SNMP-based monitor that will go out and check the output of that command and make sure it says OK. And if it says anything but okay, it'll mark the service as down. So the first thing I have to do is, you have to realize in OpenNMS, the model is always node, which is a device, an interface, and a service. And so I have to somehow associate the class monitor service with those nodes that support it. And in order to do that, I'm going to use a detector. So I'm going to modify my default foreign source, which, if you remember from the previous lessons, default foreign source shows us the detectors that are going to be used. And I want to add a detector for this object ID. So now remember, detectors and monitors are different things. For example, if I connect to port 80 and I'm trying to see if this device supports HTTP, I'll connect to port 80 and I'll issue an HTTP GET. If what comes back is a perfectly formatted 500 error, the detector will add that to the node because, hey, it's obviously a web server because it sent me a perfectly formatted error message. The difference is that in the monitor, a 500 is not acceptable. So when the monitor does a GET and gets a 500, it will mark the HTTP service as being down. Now I'm running 1901, which is the latest version of OpenNMS Horizon, and we've added a new screen to the front page. It's a status map. If I actually had added locations to my nodes in here, I only have the one node, but if I added locations to the nodes in here, they'd actually show up on this map. And we've got totally new map navigation controls. We call this Project Atlas. So we'll cover that in a different lesson, but it's definitely worth checking out. Getting back to this lesson, I'm going to go to my admin page. I'm going to say configure OpenNMS. I'm going to manage my provisioning requisitions. And I'm going to go up here to the default foreign source. Now, you can create the foreign sources per requisition. But in this case, I'm going to use the default foreign source. I'm going to leave it up to you whether to use the default or not. And what I'm going to do is I'm going to add a detector. So the name of the detector is dreadfully important. This will become the service name. And it's case sensitive. I would not use spaces. You can use dashes. You can use underscore characters. As a friend of mine used to call them underbars. He would say they were underbars. I'm going to call this class-monitor. And this is what is going to become the name of the service. It's going to get added to the services table in the database. So you want to make sure you get this part right because it's very, very important. So capital C class dash capital M monitor is what you want to call this. Now for the class, I'm going to use the SNMP detector. As you saw over there, we have a ton of built-in detectors. And so you can choose, you can use one of those and modify it and add parameters and usually use that to discover pretty much anything on the network. Now, if I left this alone, it would be just like discovering the SNMP service, which means it would connect to port 161 and it would look for, I think it's system uptime. It's either system uptime or system object ID. It's one of the basic system attributes it looks for. If that exists, it adds it to the system. But I want this to be different. I want to look for another object. So I'm going to add a parameter. And I'm going to add the OID parameter. And I'm going to put in that long string that I put in. .1.3.6.1.4.1, 8072 is in that SNP, guys. .1.3.2 happens to be the extend table. This happens to be the object. And then this, 99, blah, 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 spells out class. .1 is the instance. So my index is .1. And I'm going to save that. Now what should happen is anything that supports that object ID should get discovered. And for me, that's enough. That is enough for me to do it. Now let's suppose I had that object ID and wanted to check on a particular value. You can add that as well. So you can actually get an object ID and then check a value for it. We used to have a service called Router that we never did anything. Basically, we just looked at the MIB for the IP forwarding object ID. If IP forwarding is set to 1, this means that the device, even if it's a Windows box, even if it's a Linux box, is acting like a router, meaning it has multiple interfaces and it is forwarding traffic between those interfaces. And we used to show that as a service, but we never monitored it. I mean, we don't monitor is the thing routing. And so it confused people, so we took it out. But you can add that into the detector by putting the object ID for IP forwarding and setting the value to be 1. And then if it's any other value, it will not be added. So I'm going to go ahead and synchronize this guy. Yes. Now what it should be doing is doing an import, and it should show us the class monitoring service. So notice there's class monitor. Notice that it was not assigned to any of the other interfaces. And the reason is this. It's a little tricky. If you remember from the SNMP exercise, the default community string for this is public. So the default community string for SNMP is public, and it, by default, limits you to just the system tree. Well, this object ID is way outside the system tree. So we set up "why are you so nosy" as our community string, and we associated that with 127.0.0.1. Well, "why are you so nosy" does have access to the extend table. So that's why it's discovered on this node. However, 172.21.123 and this long IPv6 address, they are only using public. I have not gone into SNMP configuration and said, oh, when querying these interfaces, use the "why are you so nosy" community string. So it doesn't have that object ID, so it wasn't discovered on those interfaces. Does that make sense? This is kind of important. So we've got detectors. Detectors are going to go out there and they're going to detect things, and then they're going to add them to the system. But notice this says "not monitored." So we haven't configured it to be monitored. Now, when we start talking about data collection, "not monitored" is cool. I mean, we may want to monitor stuff that we do, and we may want to do data collection on stuff we don't want to monitor. So it's not necessarily bad, but "not monitored" means there is no active service monitor for this service. And we're going to change that. Okay, let's go back to the slides and catch up. So just to review, we went to our default foreign source. We added a service called C class -M monitor. It was used the SNMP detector and searched for the object ID .1.3.6.1. blah 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 .114.1, right there. Then we saved the changes. We rescanned the localhost. We could synchronize or we could rescan. Notice we get events. So it'll actually say the class monitor service has been discovered. So now we have a class monitor service. Now the next thing we have to do is get it monitored. And we're going to do this using the polar configuration. Now, let's talk about the polar configuration file. So, let me get back to my shell. Okay. I'm going to go to opt OpenNMS Etsy, and I'm going to look at the polar configuration. This is one, learn tab completion. If you're going to work with OpenNMS, you're going to be editing stuff. I don't know this is polar-config.xml. It's po-tab-etab. So polar configurations, po-tab, which will complete out to pol. We have another file called pol-outage, so it'll stop. I hit E and then tab again, and it'll complete it all out. So there's the polar configuration file. Now, a couple of things to talk about on this file. First of all, number of threads. There are 30 threads running on this system right now. This means that we can do 30 service checks. Well, we do 30 service checks at a time. Now, how do you know how many service checks you need to run? Well, you can kind of base it on the number of services. So let's say I have 30 threads, and it takes 5 seconds to do a poll, which means I can do 12 a minute. So I take 12, so I can do 360 per minute, and then I've got 5 minutes. So I can do 1,800 service checks a minute, a poll cycle, because by default it's 5 minutes. Now chances are it's going to take considerably less than that, like 2 seconds. So that would be 30 per minute, 30 per minute, 30 threads, 30 per minute, 30 threads, 5 minutes, 4,500 service checks. So in a lot of cases you don't have to up this, but you may. So you may need to go, just take a look, kind of look at your threads, and then try to figure out if you're going to need more of them. 30 is usually good for a starter, but I've upped this as high as 300. It does use memory, so you want to kind of be careful when you're doing this. This other option, path outage enabled. Path outage enabled, right here it's set to false. If you set it to true, as we talked about in notifications, we have this thing called path outage. And it's specifically for the node down notification. So when a node down event gets generated, if path outage is enabled and you've defined your paths, before sending the node down notice, it'll try to ping the upstream parent. If it can ping the upstream parent, it sends the node down notification. If it can't, it doesn't happen. And that's one way of preventing a flood of notices. It's off by default, but you can turn it on here. And then finally, we have a feature I hope you never, ever, ever use. And it's called Service Unresponsive Enabled. I almost hesitate to talk about this, but in the interest of no magic, I am going to tell you what this does. Don't use it. It's bad. It's evil. Don't use it. Back in the day, when OpenNMS was starting, our customers would sometimes complain. It would say, OpenNMS is reporting, say, my Exchange server's down. It says mail is down and it isn't. And we'd walk through exactly what the monitor does, which is it was connecting to port 25, it was issuing a hello, and it was waiting to get something back. And it was taking on the order of 10 to 15 seconds, which means you really need to fix your Exchange server. Your Exchange server is not meeting your service criteria, which was that a message should come back within 5 seconds. Anyway, they complained enough that we added this feature called Service Responsive Enabled. If you turn it on, and I'm begging you not to, if you turn it on for TCP-based services, if the TCP connection can be made, but the expected response does not come back, instead of marking a service as down, it'll mark it as unresponsive. The difference between service unresponsive messages and service down messages or node lost service messages is that the unresponsive messages did not count against availability. And I think that's just wrong. If you set your criteria to be, hey, my mail server is supposed to respond in 5 seconds and it doesn't respond in 5 seconds, that's a problem with your service, not a problem with OpenNMS. So don't turn this on. Thank you. Now, kind of in the addition of this path outage, we have this idea of what's called node outage. And what a node outage does is basically say, hey, if I get a node lost service message, so I test a service and the service is down, before I send the node lost service message, I try to ping the interface. Assuming the interface is pingable, I'll try to ping the interface. If I can ping the interface, I'll issue the node lost service message because I assume the service is down. If I can't ping the interface, there's a chance that the interface is down. Or, so when I can't do that, I'm going to generate an interface down message. And if I'm going to generate an interface down message, but before I do that, I check to see if I can ping any other interfaces on the system. And if I can't ping any interfaces on the system, I'm going to issue a node down event. And it'll suppress the interface down and the node lost service events. This can be useful if I happen to have a large device with maybe, let's say, 10 interfaces and 3 services on each of those interfaces. That's 30 services. And if we ended up getting if that node went down, I did not want to get 30 node lost service messages. I just want to get 1 node down message. So again, that's usually the desired behavior for everybody. However, we've had customers in the past who integrated with OpenNMS, and they wanted to get a separate node lost service message for every service. And they do the correlation on their end. And so you can turn this off. So you can set the status equal to off. You can also change the critical service. I mean, if you were monitoring, I don't know, a bunch of web servers, you may want to do this. I've never known anyone in production to actually change this. Because the idea is ping is pretty much the basic check. So what I would do is leave that as ICP, but again, in the interest of no magic, I wanted to show you what all those things meant. Now, after that, we have our packages. Now, I'm going to go down, skip this for a second. The package we're really concerned with is example 1. This is the package that ships with OpenNMS. Now, for each package, packages are great. Packages allow you to group together like devices and determine how they're going to be monitored. So let's suppose you were responsible for monitoring your infrastructure and you had certain really important machines. So for that, you may create, I don't know, a gold package. So you have the gold package where you monitor a whole bunch of services every minute. And then let's say you have another, standard production machines. They're not critical infrastructure machines, so you might want to monitor them every 5 minutes. So they'll get in a silver package. And then finally, you might have a bronze package which says, hey, I just want to ping this guy every 15 minutes, make sure he's up. So in that cases, you can do different packages. You can create a gold and a silver and a bronze package, and then use these filters and ranges in order to sort the devices that belong to this package. So the default filter for example 1 is IP adder not equal to 0.0.0.0. This is pretty much our null filter. It's you have to have a filter. Every package has to have a filter. And so we use this one. This says if you have a valid IP address, it passes the filter. It's going to be included in the package. Now, furthermore, you can refine based upon IP4 address ranges and IPv6 address ranges. These are just kind of here as an example. You could take them out and it would still work. You have to have a filter, but you can add and remove these ranges. Now, filters are cool. When we were talking about SNMP, and I did that joke about the system location being, North Carolina, USA, North America, Earth, Milky Way galaxy, universe. I really stress that people use that because if I wanted to monitor, let's say I had, I don't know, a whole bunch of servers in Malta, and my connection to Malta was kind of crappy, so I could expect a lot longer response times from my Malta servers versus everybody else. Well, I could create a filter here that said, system location not like Malta, and then I could create another package where it said system location like Malta. And then all my Malta stuff would be in the Malta package, all my non-Malta stuff would be in the other package. So I hope that opens up some ideas to you about how you can use different packages. And now I have another example in a second. This section here, this RD step, when we poll a service, we actually collect the latency metrics, how long it took us to poll. This configures how that gets stored, and I don't want to cover it until we talk about data collection. I want to skip this for the time being. I apologize, but basically this just stores the data that we get for the latency for the polls. And then here we list our services. There's good old ICMP. The interval, again, time in OpenNMS with the one exception is in milliseconds. So this is 300,000 milliseconds or 300 seconds, which is 5 minutes. So every 5 minutes, we're going to do an ICMP poll. We're going to wait 3 seconds for the response back. We're going to try 2 times. Notice that these are complete tries. So we'll send it out. We'll wait 3 seconds. Send it again. Wait 3 seconds for a total of 3 attempts. So retries is 2, and then there's the original attempt. So that makes it 3. And then again, these parameters determine where the latency data will be stored. And it'll be stored in a file called ICMP. We'll cover this when we talk about data collection. Now notice that all of these services have these key value pairs. Rather than hard code things into our monitor configuration, we use these because take a look at this DNS service. It actually does a lookup. And so it has things like lookup and fatal response codes that don't exist in ICMP. So this allows us to actually go in and monitor various, add various parameters to different monitors. Something with DNS, if you happen to have a bunch of, if you install OpenNMS, point at your DNS server and it's failing for some reason, what you can do is change this lookup. By default, we use localhost. This seems to work very well against Linux-hosted DNS servers. It tends to cause problems against Windows-based DNS servers. So you may want to put, www.example.com or something useful here. Notice that we have other services. We've got Elasticsearch, which actually has a URL that it looks at. SMTP has a different port. FTP can have a user ID and a password, etc. And these are all the different services we monitor out of the box. Now notice, you're not going to monitor any of these services unless they're discovered. So you've got to have that discovery piece, the detector. So the detector adds the service to the interface, and then the poller will actually to run it. Now, here's an example of, they changed it. Actually, no. So we had this really cool monitor called Strafe Ping, and it's used to monitor, let me back up a second. Okay, I want to cover this one other thing here. One of the coolest aspects of OpenNMS is the downtime model, which is this thing right here. So by default, network management platforms poll every 5 seconds. It's just what they do. It's a great, I mean, it's usually, it's not too frequent. It's not too infrequent. 5 minutes, say 5 seconds, 5 minutes. 5 minutes is a really, really good time. The problem is, for these systems, if they detect an outage, they usually don't poll again for another 5 minutes. So you're going to end up, no matter how short the outage is, you're going to end up with a 5-minute hit to your availability. Now, when I started working in network management, the buzzword was 5 nines. Can you do 5 nines? I can do 5 nines. Can you do 5 nines? For 99.999% uptime. And the problem with 99.999% uptime is that equates to roughly 5 minutes of downtime a year. So 5 minutes of unscheduled downtime a year. And when I would talk to customers, I would say, okay, what kind of service level do you want to guarantee? They go, 5 nines. I want to guarantee 5 nines. I'm like, okay, over what period of time? A decade, a score of years, a century, something reasonable? And they'd go, no, a month. Well, if you do the calculations for a 30-day month, 5 nines allows for roughly 27 seconds of downtime. And, hold on 1 second. I got a buzz on my phone. Let me log in. Got logged on my phone. Let me check my mail. Oh, yeah, the web server's down. Ding! That whole process took about 25 seconds. So the chance of me getting a notification that something's wrong and being able to fix it in 27 seconds is pretty slow. So pretty low. So what I would probably do, so in these cases, I would try and talk them down. I'd say, hey, what about 4 nines? Because if you're doing 5 nines, you might as well just say 100%. Because 27 seconds of unscheduled downtime is just, it might be doable. You might have something come up and come down, that's automated. But for someone to actually look at the problem, not going to happen. So I say, why don't we do 4 nines? Well, 4 nines on a 30-day month is about 4.5 minutes of downtime. And yeah, I could get a page and SSH into a web server and restart it and then start looking through the logs to make sure it was, find out why it died. And I might be able to do that twice and still get everything up. But the problem is with most monitoring solutions, that 5-minute polling cycle means that you're looking at 5 minutes of outage. You're blowing 4 nines to begin with. So at OpenNMS, we did something kind of cool. It's called the downtime model. And what happens is, when an outage occurs, we momentarily increase the polling rate. So the way you read this line, every package has to have a downtime model. So the way you read this line, it says, okay, beginning at time 0 of the outage and going to time 300,000 milliseconds or 300 seconds or 5 minutes. So from 0 to 5 minutes, set the polling time to 30 seconds. And this is a complete poll with retries. So what's going to happen is that if I detect an outage, 30 seconds later, I'm going to poll again. And 30 seconds later, I'm going to poll again. 30 seconds later, I'm going to poll again. I'm going to do that for 5 minutes. So you have to be careful that when you do your retries and your timeouts, if you're using the default downtime model, you don't want that whole process to take longer than 30 seconds. So basically, we're going to try, we're going to try, we're going to try, and we're going to try. And we're going to do that for 5 minutes. And after 5 minutes, I'm like, okay, I've blown 4 nines, so there's no reason to beat a dead horse. So why don't I back off? So what this line says is starting at 5 minutes and going to 43,200,000 milliseconds, which is 43,200 seconds, which is 12 hours. So basically, from 5 minutes to 12 hours, poll every 5 minutes. So we're back to normal. So it's been down. So I can have either a 30-second outage, a minute outage, a minute-and-a-half outage, a 4.5-minute outage, a 5-minute outage, or a 10-minute outage, or a 15-minute outage, et cetera. Because after that, it really doesn't matter. Now, again, so what we do is we have another line here that says beginning at 12 hours and going to 10 times 12 hours or 5 days, we're going to back off even further. And we're going to set that to 10 minutes. And then after 5 days, we're going to just delete. Now this says delete, but what we should do is unmanage the service. So what OpenNMS should do is unmanage the service after 5 days, which means you can turn it back on. We're basically saying, it's been down for 5 days, no one cares. We're just going to unmanage it. And I don't actually like that, so I want to change that behavior, but I'm going to talk about that in a second. But the cool part here is, I know The thing I like about OpenNMS users is they're self-selecting. You found this video and you've been talking for, I don't know how many minutes, 30 minutes I've been prattling on. You've listened to me for 30 minutes. And so you're obviously cool. You're probably very good looking and you're definitely smart. So one of you is obviously sitting there thinking, but hey, if I'm polling every 5 minutes, I could have a perfectly timed 4-minute and 59-second outage and you'd never catch it. And that's true. That's why you probably need to apply, if that's important to you, you have to apply the Nyquist criteria, which is for the shortest outage you can tolerate, you have to pull it twice that frequency. So like if I wanted to make sure there were no 5-minute outages, I'd have to pull every 2.5 minutes. Now, where this actually works in practice is notifications. One thing I hate, because I'm on call 1 week out of 3, and one thing I hate is when my phone goes off, and I'm like, oh, phone goes off in the middle of the night. I apologize for my wife because she's a light sleeper. She wakes up, get the phone, and I'm like, crap, one of my customers has a problem. And I have to go in the other room, get on the computer, and fix the problem. What I almost hate worse than that is as I'm wiping the sleep from my eyes and getting ready to go into the other room, my phone rings again and says, everything's okay. Sorry, we're up now. Everything's okay. What this downtime model does is during that first part of the outage, it tests it. So if it was transient, if it was due to a network issue that's now fixed or a service was restarting and it's now running, it'll actually find that out in 30 seconds, a minute, etc. And then if you add a notification delay, you don't see the notification. That's why I always put my notifications at 2 minutes. So if it's for non-critical services, if I get a notification, I'm like, I can wait 2 minutes. So if it fixes itself within 2 minutes, which will be 5 complete polls, the one that caused the outage and the 4 in the 2 minutes that came after that, then I know that the service is really down. So we've actually tested it a number of times before I get notified, which I think is cool. Anyway, we'll come back to this in a second. Getting back to packages. We have a cool monitor called StrafePing, and we put it in its own package. What StrafePing does is right now, the ICMP monitor doesn't deal very well with packet loss. If you think about it, if I actually send out a packet, ping, and it fails, and then 3 seconds later I retry and it fails, and 3 seconds later I retry and it works, the ICMP service is considered up. Now I had 66% packet loss, but the service is up. So in order to measure packet loss, we turn on this thing called StrafePing. And I actually use this at home because I'm on a DSL circuit that occasionally gets packet loss. And it's incredibly difficult to prove that to my vendor because I'll call them up and they go, oh, I can ping it, the circuit's up. I'm like, yeah, but only a few of those pings are getting through. And so what we do with the StrafePing service is we send out 20 pings every 5 minutes, 50 milliseconds between pings, and we try to see how many of those come back. And in my case, I set it, the failure ping count to 20, which means all 20 have to fail. But if I wanted to measure packet loss, if I wanted 50% packet loss, I could put 10. If I wanted 25% packet loss, I'd put 5. And it can show how many of my 20 pings have to fail before I mark the StrafePing services down. Now the trick with StrafePing is you don't want to use the downtime model because you don't want to retry if there's failures. Does that make sense? So in the StrafePing downtime model, we set this to be poll every 5 minutes for 12 days and then delete. So if it's been down for more than 12 days, we delete. But we keep the polling rate to be the same as in here. So 300,000 milliseconds. Makes sense. And notice I limit the include range, since this ships out of the box, to just a very, very small subset. Again, you don't necessarily want to be pinging the crap out of your network unless you want to, so I tend to reserve this for certain network interfaces just to make sure that I'm not having issues on the network with packet loss. So we ship these default. We have the JMX packages at the top, which we'll talk about when we talk about JMX, which is kind of outside of this class. We have the example 1 package, which is our main package for everything, and we've got the Strafer package. Now, I strongly recommend that if you make customizations to this file, you create your own package, which is what I've done for getting back to our class monitor. So what I did was I created a package, which I called package for class. Very, very unique and creative name there. package for class. If you're at example.com, I honestly think you should make an example.com package and put all of your stuff there. The main reason is, first of all of your stuff is in one group. And the second thing is when you do upgrades to OpenNMS, having all your stuff at the bottom of the Polar package will make merging a lot easier. I wouldn't even go and modify any of the services at the top. I would just turn them off and recreate them in my own package with my own criteria. Which brings up another question. What happens if you have a particular service that's in more than one package? So like the idea of the gold, silver, and bronze package is that only the gold nodes will be in the gold package, only the silver nodes would be in the silver package, and only the bronze nodes would be in the bronze package. But what if you happen to have one interface that happened to fall in all three of them, and the first one's monitoring ICMP every minute, the silver one's monitoring every 5 minutes, and the bronze one's monitoring every 15 minutes? Well, the answer is the last scheduled one wins. So in that case, if the bronze was the last package defined, it would pull ICMP every 15 minutes. So you could override everything up top by putting the same services down here. But just to make sure that's done, I always set the status here equal to off. So here's our package. So I just copied this. We're using the same kind of open IP address, IP address not equal to 0.0.0.0. Notice that we have this include range. I just left it open. These aren't required. I just tend to put them in here for both historical reasons and to remind me that this package is open up to everything. Again, here's our little RRD section, which we're not going to talk about. But then we're going to talk about the class monitor here. So I've got my service name, capital C-M, capital M class monitor. This has to exactly match what we discovered in the detector. So that's why when we created the class monitor thing in the detector, I wanted us to be very, very careful about the name. So class-monitor, capital C class, capital M monitor. Now the interval, I set this to be 30 seconds because I don't want us sitting around in this class waiting 5 minutes for something to happen. So in this case, I set it to 30 seconds. Your mileage may vary. You have to determine for you what works best. 5 minutes, I'm a strong proponent of 5-minute polls, but in some cases, 30 seconds, even 15 seconds might be called for. Since I made this service up, I set user defined equal to true. We don't really use anything with this at the moment. One of the ideas we've thought about is during upgrades to kind of treat these differently, and then user defined equals false. And then status equals on. You can create complex service definitions and then just set the status equal to off, and you can turn them on when you need them. And then since we're going to use the SNMP monitor, we have certain parameters that only deal with SNMP. The first one is object ID. Remember that long object ID? Well, there we go. There's that long object ID. Remember this 99 blah, blah, blah. That's class monitor. This is line 1. That's our OK line. And we're going to actually look at operator value equals OK, is equals. This can be equals. This can be less than, greater than, less than and equal to, greater than or equal to. Or if you put a tilde here, that little tilde character, you can make that regular expression. But in this case, we're going to say it with equals, and the operand is OK. So basically, we're going to say get this object ID and make sure it equals OK. If it equals OK, then the service is considered up. If it equals anything other than OK, the service will be marked as down. Make sense? And then every package has to have a downtime model. So there's the downtime model. Now, one last thing we have to do. I know this is a lot. So remember, we created our package. We added our service to the package. Notice that in this service definition, there is no indication of what type of monitor class monitor is. This gets defined at the bottom. So at the very bottom of the file, we list all the different monitors we ship with. That's all the ones that we ship with. And this is the one I added. So I said class monitor uses the SNMP monitor class. The reason we did this, like in the detectors, they're included, you include those with each detector. You include the class or the type of detector you're using. Monitors, on the other hand, we expect our customers to have lots and lots and lots of packages. So we don't necessarily want them typing this huge string over and over again. So that's why we put it at the bottom. So anywhere in this file where I reference class-monitor, it's going to know to use the SNMP monitor code. One place this came in handy was here where we have SSH. Where's the SSH monitor? Here. In the bad old days, the SSH monitor was actually a TCP monitor. All we did was connect to port 22, right? Connect to port 22, and we would issue, we would see if the characters SSH came back, and if it did, we would say, hey, this is SSH. The problem is that actually caused logs, because when you connect to an SSH service, it actually expects you to send version information back. When it responds to you, it says it expects you to respond back, and if you don't, it's causing logs. And you know, our users tend to have a little bit of OCD. I'm no exception. And we had people complaining, OpenNMS is causing all these logs to appear in my system. And so I decided I'm going to create an SSH monitor. And I did it kind of like an expect script. So basically I said, okay, we're going to issue we're going to make the TCP connection. We're going to see if SSH comes back. If SSH comes back, then we're going to send a version number. And that worked fine. Log went away. Everybody's happy. Except, so I made some mistake and my monitor did not close the connection out. So 5 minutes later, it would open another SSH connection. And 5 minutes later, it would open another SSH connection. And I think the default number of SSH connections, at least on Linux, is something like 40. So basically, this was back in the 1.1.3 days or something like that. I basically DOSed all of my users' networks because they were using the SSH monitor, and after 3.5 hours or so, they couldn't SSH to any devices, including the OpenNMS box. This is what they needed to stop OpenNMS to clear up all the errors. So I scrambled to the mailing list and I said, okay, change this to be TCP monitor, restart OpenNMS, and your problem goes away. And then later on, Ben Reed fixed the SSH monitor and made it as pretty as it is today, and it actually works and doesn't do logs, etc. But that made one case. You were able to change just a few characters in this file, restart, and you ended up getting the monitor to change. So that's one of the main reasons that we put all the monitors at the bottom. So again, what you'll need to do is, when you create this, is you'll need to add a package for your services, and then make sure any new services that you add are defined down here at the bottom. Okay, now, so you don't have to do that. I actually put them up in our, I need to change that URL. That's not going to work. This is going to be, if you go to the training slide, so if you go to index of training/config, I'm going to refresh this, and you'll see there's an exercise 8. Grab that URL. So copy that link location, and you can do the wget and get it back. I obviously copied this from another slide where I had the files up over there. So you wget -n, which will clobber it. Otherwise, you'll end up with a polar configuration.1. But copy that file, or you can merge the changes in. Remember, if you click on this, don't use the browser version because it puts all these little dashes in. Instead, you can look at the source. And then if you look at the source, you can see down at the bottom here is where I put my package for class. So you can actually copy that, paste that into your polar configuration, and remember to grab the monitor line down here at the bottom. Okay. Now, you can at this point in time, you can restart OpenNMS, but I want to try something. So let me go back to my web page. As you can see, I'm going to refresh. Notice the service is not monitored. We are trying to make it so that you can restart each individual daemon in OpenNMS without having to restart the whole thing. That was that daemon config, this reload daemon config that we did for event D. Well, the daemon for the polar is polar D. So I can send that event. How do I know it's polar D? If I do an opt OpenNMS bin OpenNMS and then use the -v status command, it'll show me the status of OpenNMS, and it'll show you all the running daemons, and there's the polar D daemon. So I just restarted polar D, and in the past, it didn't work. But with 1901, you'll notice that now my class monitor is set at 100%. So now the not monitored has gone away, and I'm actually monitoring my service, and I did not have to restart OpenNMS. That I think is pretty cool. So, especially in systems where you want to limit your downtime, now you can just reload the polar configuration. So now, what I want to do is test it. So let me go back. If you remember, we put our file in temp. So I'm going to edit my class monitor shell script, and I'm going to change it to not okay. I'm going to save it. I'll go back here. Now, if you remember, we set our polling rate to be 30 seconds. And so the cool thing is within 30 seconds, assuming all this went right, within 30 seconds, this class monitor should be marked as down. This is the part where we dance. A few more seconds. Haha, this may be where I need to restart. Yeah, it doesn't look like this is working. So obviously, I ran that reload daemon config file, but it didn't work. See, I went to the page. It'll actually show you the parameters and stuff that we configured, so we know all that's right. But it's not marking it as down. So obviously, there's still a problem with that reload polar config. I apologize. Well, at least we know now. So what I'm going to do is opt OpenNMS bin, OpenNMS stop. I'll stop OpenNMS. Now, when I start OpenNMS, it'll obviously notice that the service is down. Just to show you that that's not that I don't need to do that for the particular outage. What I'm going to do is I'm going to edit the class monitor shell script again, and I'm going to put it back. Yeah, I apologize for that. See, that's what I get for making stuff up in the middle of a video. So let me change this back to OK, and we'll start her up. While this is starting, I'm going to jump back to the slides and kind of review what we've done. So we created a polar package. And again, I strongly recommend you create your own polar packages for your stuff and put them at the bottom of the file above the monitoring list, because it'll make it easier to merge when we do upgrades. Again, I created a filter that basically said everything, IP address not equal to 0.0.0.0, service name set to class monitor, interval of 30 seconds. Here's that long object ID that I basically cut and pasted from our walk. We set it equals to OK, which means it has to equal OK exactly. If I wanted it to just contain the letters O and the letters K, I could put a tilde in here, and that would make it a regular expression. And when we have our downtime interval. And remember, we have to add our monitor line. Every new service we add, we have to add at least one, we have to add this one monitor line to tell OpenNMS what monitor to use. And in this case, we're using the SMP monitor. Then we talked about the downtime model. Again, what the downtime model allows you to do is temporarily increase polling when there's an outage. The main reason for this is to determine as quickly as possible when an outage is resolved so it doesn't impact your sleep. So what you can do is on notifications, you can add an initial delay, and then if there's a problem, you know that it's been polled, it's been down for a certain amount of time, and that several polls have been attempted, and you can actually do that, set that here. So that's what we do. So what we do is from 0 to 5 minutes into the outage, we poll every 30 seconds. From 5 minutes to 12 hours, we poll every 5 minutes. From 12 hours to 10 times 12 hours, or 5 days, we poll every 10 minutes. And then we unmanage the service if it's greater than 5 days. Now, I don't like that because I travel a lot, and sometimes there'll be a machine in the office that I'm responsible for, and if I'm gone for a week and it goes down, maybe it won't get fixed. So when I come back, I have to remember, hey, that went down. I have to go and forcibly manage the service back through the GUI to make it the monitoring start. So to fix this, what most people would do is delete this downtime begin line, which is part of the answer. Let me jump back to the polar config. Just to kind of do this on the screen. So a lot of people say, oh, well, I don't want to delete the service, so I'll delete that line. And that's half the answer. The problem is, if you delete that line, what will happen is, let's read what we told the computer. We told the computer right here, we said, okay, from the beginning of the outage, for 5 minutes in the outage, poll every 30 seconds. From 5 minutes to 12 hours, poll every 5 minutes. From 12 hours to 5 days, poll every 10 minutes, and then stop. Since there's no line, since we have this end here, polling will stop, and that service will never, ever, ever, ever come back up. So if you want to get rid of the automatic delete, delete the end. Doesn't need to be there. So if you delete the end, what will happen is now it'll poll 30 seconds for the first 5 minutes, every 5 minutes for the next 12 hours, 10 minutes forever. And that's what I do. That's what I do for all my services because I don't want them to be forcibly unmanaged. And so I changed the downtime model for all of my systems. Okay, well, quit out of here. Okay, let's go back. We should be able to refresh this. Have to log back in since we restarted. And so notice the class monitor system is still up. And I'm going to make it go down. So I changed it to not okay. Now, within 30 seconds, we should see this go down. I apologize for that reload dimming. The polar configuration file is the one we were having the most trouble with. So you saw it actually reloaded the monitor, but it obviously didn't schedule it. And so it actually wasn't being polled. Now you see, boom, within 30 seconds, I get class monitor outage identified with reason code. And this is another thing I like about OpenNMS. It tells you why the poll failed. The observed value of not okay does not meet the criteria that it has to equal okay. If SNMP were down, I'd get another outage. I'd get a could not connect outage. And so it does give you some idea of what the problem is. So now let me go back. Remember, right now my downtime model's kicked in, so I'm still doing 30-second polls. And now within 30 seconds, we should see it come back up. And just like before, all of these node loss service messages and node regain service messages are actually creating alarms. So we're getting alarms, we're getting notifications. All of that good stuff is still working on our brand new service here. As I look, there we go. Whew, I was getting a little worried there. So class monitor outage has been restored. And so if I go to my alarms, all alarms, you'll see there's the service here. If I hit refresh, the bottom one should clear because of the, and then we have a 30-second, the cosmic clear model is kicking in. Man, my time is just, there we go. My timing is just off. And then the same thing is, notice we have no notices, but if I actually go and look at notifications, all acknowledged notices, you'll see the class monitor service did create a notice and then it was auto-acknowledged when it came back up. And this is the beauty of it. If you put an initial delay in, you're not getting monitored. You're not getting notified. So I think that's cool. So this works well with all of the different monitors we have, and we've got a ton of them. If you're, say, you're coming to OpenNMS from a tool like Nagios, and you're used to check scripts, well, you can use this extend functionality in NetSNMP to schedule your check scripts. So you can just run your check scripts on your box and then have OpenNMS query it via SNMP. If you actually use NRPE to run your scripts, well, there is an NRPE monitor. So you can do the same thing with OpenNMS using the check scripts. The benefit will be, because everything is done in a Java virtual machine, it scales. We're not actually doing a fork exec. If you absolutely positively have to run something that requires a script, we have a general purpose monitor, which will execute scripts. I don't talk about it very much because it's not something I like, mainly because it's so expensive as far as resources go. You can't monitor 10,000 devices with that, but you can monitor 10,000 devices with SNMP or any of our other monitors. So, getting back to our slides. So that's the downtime model. Here we restarted the OpenNMS. Again, the send event command did not work. It worked halfway. I will open a bug to make sure that we're still working on that, but it worked halfway. We tested it. Notice that we changed OK. I changed it to not OK. It told me what I did. And then finally, I want to talk about a thing called scheduled outages. So when we were talking about like uptime, 99.99% uptime and all that good stuff, I mentioned unscheduled downtime. Well, what about scheduled downtime? Well, you can do that in OpenNMS. We have this ability. If you go up under Configure OpenNMS on the admin page, and you go up under Node, I think it's where's keep moving under Service Monitoring, obviously configured scheduled outages. This allows you to create outages. So I can do something like outage for class. So we'll add a new outage. And you can do nodes or interfaces. So I'm going to do localhost because that's our node, and I'll add it. So I've added our node, and I could say I could do daily, weekly, monthly, or specific. So let's say daily, and let's make it from, I don't know, 1500. Let's make it 1500 to 1400 to 1600. Well, 15,999. So we'll make it there, and we'll add that outage. And then what is the effect? You could have it affect just notification. You could have it do polling, etc. So I'm going to check our package for class polling rate. Now I want to stress, this is a poll outage. What this means is we do not poll during this time. So let me save this while I talk about that. So I'm saving this class, and you see it's red now, which says it's actually in progress, because if you look at the time, it's set up in progress. Now if I go and I change, wrong one. I change the class monitor to be not okay like I did before. Notice that I will not get any indication. And the reason being that we are not polling this particular node during the outage window. Since we're not polling it, we'll never know that it's went down. And therefore, it's kind of like see no evil. We just won't notice it went down. So it's critical to understand how poll outages work, how scheduled outages work. Let's say you have a standing maintenance window from, I don't know, from 2 a.m. Sunday morning to 3 a.m. Sunday morning. So you put in a standard outage every Sunday, because you can do a daily outage, you can do a day of the week outage, you can do a day of the month outage, and you can do a specific outage. So let's say we said every Sunday from 2 a.m. to 3 a.m. there's no, we have a scheduled outage because that's when we want to do maintenance. Well, I don't know about you, but if I'm up at 1:30, 1:45 in the morning on a Sunday, I might be eager to get it over with. Hey, I want to go back to bed. So let's say I start my maintenance window at 1:59 instead of 2 a.m. So at 1:59, I start doing stuff. If OpenNMS happens to poll during that time, then what will happen is we'll mark it as down. The moment we enter the outage window, we won't do anything. So it will stay down for the entire hour, and then at the end of the hour, it'll come back up. And so I'm going to refresh here. As you can see, there's no outage. It's obviously been more than 30 seconds. And this is because the node is currently in an outage window. So it won't know. So if I go back here and turn this thing on, make the service come back up, we'll never see the outage. We'll never get a notification. We'll never get an alarm because a poll outage is going on. And now in about 10 minutes or so, this outage will clear. This little warning will go away from the node. And then if I bounce it, it'll work. Make sense? So that's kind of it. That's kind of it for service monitoring. I mean, there's tons of stuff we're going to do after this. We're going to start examining one of our more complex monitors called the page sequence monitor. We're actually going to talk about how do we create services for things we can't poll. We have a thing called the passive status keeper for passive services that we can't poll. Lots of cool stuff to talk about with OpenNMS. Anyway. I hope you folks found this useful. Sorry for the mess up on the reload daemon config. Please check this out, play along, and I hope you find these things useful. Feel free to talk to us at chat.opennms.com or in the comments section of YouTube. And until next time, hope you're having fun with OpenNMS.